Hi students, how are you? I hope that you are all preparing well for your examinations. Last few days onwards, I am teaching limits, continuity, differentiability, differentiation, maxima and minima, local maxima, local minima, global maxima, global minima, all those topics I am explained, and a few problems also I did on the basis of those topics. So, in our continuation of this chapter, our branch of mathematics, that is calculus, our next topic is integration. Very important topic, this is integration. So, if you have a command over this integration, next chapter is definite integration, that is also will be very useful to you. A very good number of questions are coming from this chapter, integration. So, what is integration? In this integration, basically two types of integrations are there. One is indefinite integration, another one is definite integration. One is indefinite, another one is definite. Definite integration, right? This indefinite integration is the nothing but reverse process of differentiation. I will explain what is that. Reverse process of differentiation, whereas a definite integration is area of the curve, area under the curves. This is a major use of this definite integration is how to find out area under curve. That means if there are irregular shapes are there, for example, x-axis, y-axis, there is a curve y is equal to f of x, and there are two ordinates x is equal to a and x is equal to b. X is equal to a, there are x is equal to b. How to find out the area enclosed between y is equal to f of a and x is equal to a and x is equal to b, two lines, and x is x-axis. If you want to find out, this is an irregular shape, if you want to find out it is neither a square shape nor a rectangle shape nor a rhombus shape, it is a irregular shape, then how to find out the area of that figure? So, if you want to find out this type of areas, you should have the basic knowledge of indefinite integration. Okay, now, what is indefinite integration? Why, how it arises? What is the concept behind this indefinite integration? Let us learn detailed. Okay, now let me explain how this integration will come. Okay, now let us go to differentiation. We know that the derivative of x square is 2x. We know that what is the derivative of x square is 2x. Already we learned. Here 2x is called the derivative of x square. Underline the derivative. I am saying not a derivative. I am saying the derivative of x square. If you speak in a reverse way, x square is called, then there is a number, there will be definitely in the reverse also there should be some terminology. Everybody knows that 2x is the derivative of x square, but what about x square is then what to think, no? That x square is called antiderivative of 2x. This is important. If 2x is called the derivative of x square, then x square is called antiderivative of 2x. Okay, now the question is, if you know the function, we know its derivative. That means what? If I know d by dx of sin x, now you are saying cos x. What is the d by dx of 1 by x? This is minus 1 by x square, you are saying. Happy. But my question is, there is a function, I don't know that function, its derivative is some 4x cube. its derivative is 4x cube. Then what should be your function? That is the question arises. Understand this? So, if given a function, you can find out the derivative. If you know the derivative, how to find out the given function? Their questions arises. That means if d by dx of one function is f of x, we don't know the function is f of x. Let its derivative is capital F of x. Let it be derivative is capital F of x. We want f of x. We know capital F of x. We want f of x. Okay, now that f of x is given by the integral of f of x dx is equal to f of x. Okay, plus c I will tell. Why you have to write down plus c I will tell. Okay, why you have to write down plus c? Now let us see that example. What is the derivative of x square? This is equal to 2x. What is the derivative of x square plus 1? This is also 2x. What is the derivative of x square plus 3? This is also 2x. So on, what is the derivative of x square plus c? This is also 2x. That means the integral of 2x dx is equal to x square plus c. The integral of 2x dx is equal to, as per the notation, the integral of f of x dx is equal to small f of x. Then what have to write down? A constant of integration. Understand? In this symbol, each letter have its own meaning and own terminology. Okay, na? I will explain each and every terminology. Okay, na? Let us see that. Welcome back. Here already I told integral of f of x dx is equal to capital F of x plus c. Here let us see this one by one. Small f of x, capital F of x plus c. First you have to learn the name of this function, that which is going to be integral. We are going to integration. This is called integrand. This is called integrand. This f of x is no. This is called integral. It is called integral, or another name is also there. Antiderivative, or another name is also there, primitive. See here, what are the answer we got? That answer, that is called integral or antiderivative or primitive. This f of x is there, no, that is called integrand. The function which is going to be integral is called integral, and the output, whatever may be the output we got, that is called integral or antiderivative or primitive. Understand this? Coming to this small c, what is capital C, what may be this? This is called constant of integration. Constant of integration. Understand? We got this constant of integration. This is called, this symbol is there, no, this is called sign of integration. This is called sign of integration. This symbol is called sign of integration. Coming to dx, this dx is called with respect to which variable you are integrating. So, with respect to x, you are integrating the function. Okay, na? So, everything is clear. Okay, na? Now, I am going to explain what is the meaning of x square plus whatever may be that x square dx is equal to. So, you are saying, so this is you are saying x, if it is a x square, you are saying x cube by 3 plus c, x cube by 3 plus c. If it is 2x, integral of 2x dx is there, it is x square plus c. What is the meaning of this? What is the meaning of this? What is the geometrical meaning behind this? What is the geometrical meaning behind this? Let me explain. Let me explain the geometrical meaning of this integral. Okay, now for example, integral of 2x dx is there. Integral of 2x dx is, that means what I have to told, I am not explaining the formulas here. So what I am going to do this, what is the function whose derivative is 2x? What is the function whose derivative is 2x? This is nothing but x square. So therefore this is x square plus c, you are saying x square plus c. What is the geometrical meaning of this? Means here not only x square plus c, this is x square plus 1, this is x square minus 1, whatever will be that, x square minus 1, x square plus 2. For all these 2x dx, the answer is either x square plus c, x square plus 1, x square minus 1. How many answers you will get? Infinite number of answers you will get. That's why it is called indefinite integration. So this type of integration is called indefinite. So you are getting indefinite, not a single answer you are getting. You are getting so many answers you are getting. That's why it is called indefinite integration. Okay, now, right. What is the meaning of this? Let us draw the diagram. So this may be x square where constant of integration is 0. Right. Y is equal to x square. What is the graph of y is equal to x square? This is y is equal to x square graph. Over. Next one, x square plus 1. This is x square plus 1. This is 1. Next one, x square minus 1. X square minus 1. So this is minus 1. X square plus 2. Now what you are getting? X square plus 2. What you are getting? All these are all family of lines. Family of lines. What is this? So integral 2x dx is equal to whatever may be the answer, you will get x square plus c. Other whatever may be that answer you will get, they are family of curves. Curves may be anything, family of curves, not lines, curves. Whatever may be that curve, maybe straight lines, maybe whatever may be the output answer you are getting here, x square plus c, that is nothing but family of curves. In this our example, we got the parabola. So these are all family. How many members are there here? We have infinite number of members are there. Infinite members of y. Why? Because c is a real number. So once one number, if you give the input to this, you will get one member. If you give one number to this constant, you will get the output will be one member. Okay, now right. So this is nothing but a family of curves. So geometrical meaning of this is the whatever may be the output you are getting, that is nothing but geometry, that is nothing but family of curves. Okay, now right. Since we are getting an infinite number of answers, there is no definite answer. That's why this is called indefinite integration. Okay, right. Definitely there exists a number x is equal to some x naught, whatever may be that, some x is equal to x naught, x is equal to a, or x is equal to b, what number. At that, definitely at that number there exists a tangent, definitely there exists a tangent parallel to each other. In this, x is equal to x naught, draw a tangent, draw a tangent, draw a tangent. All these tangents are parallel to each other. In this family of curves, x square plus c, in this family of curve x square plus c, all these tangents will be parallel to each other. Definitely there exists a number x is equal to a such that in that number, if you draw the tangents to all the members, they are all parallel to each other. Understand this? Parallel to each other. Okay, now right. That is the geometrical meaning of the integration, definite indefinite integration. Okay, now so let us move to next concept. Here students, see here I am directly taking the problems from this indefinite integration. So why? Because all these list of formulas all are available with you. I don't want to waste by explaining all those formulas, their derivation. So I don't want to waste your valuable time. I will straight away go for this chapter, indefinite integration. Okay now. So here all the formulas are within you, in your materials it is there. So now here problem solving techniques we have to improve. Let us see one problem. Such type of problem is given in 2018 mains. So the problem is integral of sin square x into cos square x upon sin to the power of 5x plus this is cos cube x into sin square x plus sin cube x into cos square x plus cos cube x whole square dx. Okay now. So this is the problem given. We have to find its integration. So what will be your answer? Okay. So then how to proceed this problem? So this type of problems here you see here sin to the power of 5 whole square. That means sin to the power of 10 you will there. So multiply the numerator and denominator, sorry, divide the numerator and the denominator with cos to the power of 10x. That is the first idea you have to get. So that the problem will become in tan and secant, the solution will be very easy. So divide the numerator and denominator with cos to the power of 10x. If you, the first idea that you have to get that only. Okay now. So then the problem will be easy, right? So first if you divide with here cos to the power of 10x. Okay. So cos to the power of 10x. If I divide here cos to the power of 10x, see here. If I divide here cos to the power of 10x, how many cos's will be get cancelled? 2 cos's will be get cancelled. Take 2, that means here cos square, cos to the power of 8x, cos to the power of 8x. Take 2 cos's to this side and this will become tan square x into 6 cos's will be there. So this is equal to secant power x dx. So once again I am telling, I am dividing the numerator with the cos to the power of 10x. 2 cos's will get cancelled. 8 cos's will be there, cos power 8x. Take these 2 cos's to this side, sin square x by cos square x. This is tan square x. Cos to the power of 6x. Take it into numerator, secant power 6x. Okay. Divided by. So denominator is very, very important. So if I divide this denominator also with cos to the power of 10x. Okay, cos to the power of 10x. When this cos to the power of 10x it is went inside this bracket. So this bracket, then it will become 5. Why? Because already whole square is there. If it is inside, enter into the inside bracket, this become cos to the power of 5x. Why? Because already 2 is there. Now see here sin to the power of 5x, cos to the power of 5x. So this is equal to tan to the power of 5x plus, see here sin square x 1 cos square x. So this is equal to tan square x, tan square x, cos cube x, here also cos cube x gets cancelled. Okay, very nice. Plus here sin cube by cos cube, sin cube by cos cube, tan cube x, cos square x will get cancelled. Okay now, plus, very nice. Here cos to the power of 3x, cos to the power of 5x. In the denominator cos to the power of 2x will be there. If it comes to here secant square x, secant square x whole square dx. Okay, so very nice. The total problem, here the given problem is sin and cos. Now the problem will become in tan and secant, so that the problem can be solved very easily. Okay, so the first thing is you have to get this idea, dividing the numerator and denominator, so that the problem will become in sin and tan and secant. Okay na, right. See here, this is a tan square x into secant power 6x divided by, observe here factorization we will do here, any more factorization, right. This secant square x, again one more step I will write down, one more step. that is equal to this secant square x, I will write it as a secant square x, I will write out. This is a tan to the power of 5x plus this is a tan square x. This is secant square x is equal to secant square x minus tan square x is equal to 1. Secant square x is equal to 1 plus tan square x. Already tan square x is there. So, can I write down 2 tan square x plus tan cube x plus 1 dx. So, secant square x is equal to 1 plus tan square x. Already 1 tan square x is there. 2 tan square x plus 1 dx. Of course, square is there. Okay now. So, next step, that is equal to integral of this is a tan square x into secant to the power of 6x by, is there anything to be taken common outside? Anything to be taken common outside? Okay, anything to be taken common outside? See, one thing here, there is a small change. Here it is 5 should be there. Here it should be 5. So, that cos to the power of 5, cos to the power of 5 will get cancelled. It will be 1. Okay, I am sorry. Cos to the power of 5, cos to the power of 5 will get cancelled 1. So, now this 1 plus tan cube x, this is tan square x plus 5. Here I can take, so I can take this is tan square x common outside. So, this is equal to tan cube x plus 1. So, this is equal to tan cube x plus 1. Again, I can take this side 1 plus tan cube x into 1 plus tan square x. Here whole square is there, no? The square will come for both the terms. Okay, now? Right. This 1 plus tan square x is equal to secant square x, that is secant to the power of 4x. Here it can be cancelled. Okay. So, let us continue the solution. So, welcome back here. See here, this is equal to integral of tan square into secant power 6x by 1 plus tan cube x whole square into 1 plus tan square x is equal to secant square x whole to the power of square is there. This is secant power 4x dx. Okay now. Secant power 6x, secant power 4x, 2 gets will be cancelled. So, this is equal to tan square x into secant square x by 1 plus tan cube x whole square dx. Okay now. Understand this. Up to that, very happy. Now, see here 1 plus tan cube x. 1 plus tan cube x derivative is equal to how much? 1 plus tan cube x. For 1, 0, 3 tan square x, again tan x derivative is secant square x. Try to understand here. 1 plus tan cube x. 1 plus tan cube x derivative is tan cube x, that is equal to 3 tan square x, again tan x derivative is secant square x. But here 3 is not there, that is why what I will do now, multiply and divide with 3. Okay now. So, if you observe very clearly, 1 plus tan cube x whole square, this is equal to 3 tan square x plus secant square. So, the derivative of this is nothing but this. That means your answer is this is in the form, that is equal to f dash of x by f of x whole square dx. Okay now, right? So, now you can forget about this f of x derivative is in the numerator. So, we have a list of formulas. In that formula is 1 by 3 into f of x whole power minus 2 will be there. F of x whole power minus 2 integral minus 2 plus 1 by minus 2 plus 1. So, this is equal to, that is f of x whole power minus 2 plus 1 by minus 2 plus 1 plus c. So, ultimately this is minus 1 by 3, 1 by f of x. What is our f of x? This is 1 plus tan cube x whole square. Understand? Plus c. This is minus 1 by 3 upon 1 plus tan cube x whole square plus 3. So, here check here. So, not whole square. So, this is minus 2 plus 1, no, only 1 will be there. Minus 2 plus 1 is minus 1. So, this is denominator will come. So, option 3 will be your right answer. Understand this? So, try to understand here, this will be cos to the power of 5x. This is sin to the power of 5x. No, this also should be cos to the power of 5x. Then only if you multiply and divide with, you will get the answer. Okay, na? So let us see the next problem. Welcome back to second problem. The integral of secant square x upon secant x plus tan x whole to the power of 9 by 2. So this was asked in 2012 advanced examination, single correct answer type. Okay, now so options are also available, but they are very lengthy options, so that's why I have not have written. So let us see the answer. Okay, then how to proceed? Right, everybody can do this problem. Already it is in the secant and tan x, but don't convert it into sin x and cos x. Okay, so put it like that only, right? Secant x plus cot tan x. Then how to proceed? As we will proceed like this. Let us put secant x plus tan x is equal to t. Okay, na? Right. Secant x plus tan x is equal to t. Then what we will put in the secant x? Here we will put t. Then what we can put in the secant x for that? We know that secant x minus tan x is equal to 1 by t. Okay, so if you add it, 2 secant x is equal to t plus 1 by t. Therefore, secant x is equal to 1 by 2 of t plus 1 by t. Happy. So, in place of secant x plus tan x, I will put t. In place of secant x, I will put 1 by 2 times t plus 1 by t, right? Happy. Then what about dx? What about dx? In place of dx, to find out that, differentiate secant x plus tan x into with respect to x. Secant x derivative secant x into tan x plus tan x derivative secant square x. Of course, here dx will be there, that is equal to dt. Take secant x common outside. So, here tan x plus secant x dx is equal to dt. Okay, now, right. Secant x plus tan x is again t. So, therefore, secant x into t dx is equal to dt. Okay, so put it like that, no problem. Why? Because here secant square x, no, secant x into dx, secant x into dx. So that is equal to secant x into dx is equal to 1 by 2 dt. Okay, now secant x into dx, I will put secant x into dx 1 by 2 dt. One more secant x will be there. In that secant x, I will put 1 by 2 times t plus 1 by t. Okay. So these are all the arrangements that we have to make before directly entering into the problem. Okay. So let us substitute all these values here. So the problem will becomes in terms of t, and that solving that problem is will become very easy. Okay, na? So let us continue this. Welcome back to our calculation. So here everything is I prepared. Secant x plus tan x is equal to t, secant x is equal to 1 by 2 t plus 1 by 2, secant x dx is equal to dt by t. So everything you substitute there, and we will let us see what happens. So this is equal to integral of, this is secant square x, no, secant x into secant x. 1 secant x dx is equal to dt by t, dt by t divided by 1 secant x is equal to this, that is equal to 1 by 2 times t plus 1 by 2. This is a secant x plus tan x is equal to t to the power of 9 by 2. Okay, now then how to proceed this problem? So very nice, almost the problem is over. This first 1 by 2 take common outside, take 1 by 2 common outside. This t is no, you divide in the both numerator and denominator, you subtract. If you divide here, this is a 1 plus this is a 1 by t square by t to the power of 9 by 2. Separate this. So this is a 1 by 2 into, this is 1 by t to the power of 9 by 2 plus 1 by t to the power of 9 by 2 into t square. 9 by 2 plus 2, 9 by 2 plus 2, how much? T to the power of 13 by 2 dt. Okay, now, right. So this is equal to 1 by 2 integral t to the power of minus 9 by 2 plus t to the power of minus 13 by 2 dt. Okay now, right. Now we are finding the integration. So this is equal to 1 by 2 into t to the power of minus 9 by 2 plus 1. That means x power n integral is x power n plus 1 upon n plus 1. Plus 1 means how much? Minus 7 by 2 by minus 7 by 2 plus. This is also t to the power of, right, minus 13 by 2 plus 1. Plus 1 means what? Minus 13 plus 1. Minus 11 by 2. Minus 11 by 2 by minus 11 by 2 plus k. So the integration part is over. The integration part is over. Now we are going to simplify. So here very logically you simplify this. See here 2 get cancelled. Minus minus is there, take minus outside. Okay, so the your problem will become minus integral of 1 by t to the power of 7 by 2 plus 1 by t to the power of 11 by 2. Of course, here 7 is there, here 11 is there. Understand this? But if you put t is equal to secant x plus tan x, your answer is not in that form. Answer is not in that form. Answer is in something different form. Okay, that is something lengthy that I will show you. Now what I am going to do is t to the power of 7 by 2 I am taking common outside. T to the power of 7 by 2 I am taking common outside. So that is equal to, sorry, t power 11 by 2 I am taking common outside. So that is equal to minus 1 by t to the power of 11 by 2 I am taking common outside, 1 by 7 into just t to the power of 11 by 2 only common outside. Then what should be there in place of t to the power of 7 by 2? So to compensate that, this should be t to the power of if it is minus 2, okay now. See here 11 by 2 minus 2, 2 2s are 4, 11 minus 4, 7, 7 by 2, okay, plus 1 by 11, okay now. Understand this. Take that in the numerator, minus 1 by, now I am writing final answer, that is equal to, this is your final answer, minus 1 by, what is your t value? Secant x plus tan x. This is equal to secant x plus tan x whole to the power of 11 by 2 into, this is 1 by 11 plus 1 by 7 into, this is 1 by 2 to the power of minus 2, that is t square. That is equal to secant x plus tan x whole square. This is your final answer. Of course, plus k is there. Okay. This is your final answer. That is minus 1 by secant x plus tan x whole to the power of 11 by 2 into 1 by 11 plus 1 by 7 times secant x plus tan x whole square plus k. This is the option. Okay. Actually speaking, up to here the problem is over. But in the options, this in this format it is there. That's why we are struggled hard to get this problem. So this was asked in 2012 advanced problems. Okay. So dear student, I hope that you enjoyed today's class with some more problems and some more topics. In the tomorrow's class, I will come before you. Until then, all the best.